Okay, we're now ready to start placing some components and some tracks on our board. So first of all though, there's a couple of things I want to change and check. I'm going to change the colour of one of my layers, the top overlay. This is for putting text on the top of the board, which might be special instructions or indicate certain things to the installer or the service person. I'm not really happy with that layer being in white, so I'm going to change that. So up here in settings, we go layers, and the top overlay, I'll make that bright yellow. That's another standard colour. And I'm going to go back to the bottom layer, and I'm going to make sure that I've got a good track width there. 25 thousandths of an inch track width. So we're back in Imperial. I've switched to mils, and it's 25 thousandths of an inch as my default track width for this project. So let's place a component. You can place a component anywhere, but really what happens is when you place a component, the pads will automatically go to the bottom layer, if that's the layer that you're on, but the shape and the image of the component will actually end up on the overlay. So let's place an IC, an 8-pin IC, which might be a 555 timer or an op amp or something like that. That's what it looks like, and we're going to place it now. We'll call it 555, and this is IC number 1. So at the moment it's still hovering there, and when I press the space bar I can position the chip whichever way I want. So let's make it that way, and we'll put it right in the middle of the board for now. According to my circuit diagram, I might need a couple of resistors, so let's do that. And resistor is actually what we call axial if they're lying flat on the board, and 0.4 is a pretty standard lead spacing for a small value for a small power size resistor. So let's place him. Once again, it wants a name. You don't have to give it a name, but I'm going to call it R1. Let's do that again. Same component, we'll place it. This time you'll notice that it's automatically incremented it to R2. And for whatever reason, I need this one to be going in that direction. Now let's join this up with some tracks. So on our bottom layer, I click on the track button, position myself right in the center of the pad, escape. What you want to avoid is you want to avoid sharp angles. So rather than doing a 90-degree turn here, I did a nice neat 45. What we might also want is perhaps a positive rail for our power supply. So we might just put a temporary line in there for now and start feeding our devices where it's needed. You can move the components, you can shorten, cut the tracks, you can make them fatter, you can change the size of the pads and all those things, all just through edit and setup. Okay, so let's edit a couple of things. First of all, I think these tracks here are a little bit thin, so double click on the track, and what we can do there is we can change this value. Now our track is much fatter. You also want to avoid these corners here like this, so what I could do is I could place some extra track in there like that, and that makes everything look a lot tidier. How about we also change the size of this pad here? happy with it being a circular pad, but let's make it 100 by 100. Done. Now of course if your pads get too large they may be touching each other or cause possible shorts, so you need to be careful. Okay, so our circuit is starting to take shape. As we start to build our tracks according to what our circuit diagram says the components should be doing in relationship to each other. This is where you need to keep a close eye on the actual pinouts of devices like transistors and chips to make sure that you are actually looking at the correct pin and that you are aware that you are looking down over the top of the components as if you can see through the circuit board. Let's place a couple more components and a string. So I want to place a transistor around here perhaps. So we're going to go to our components and we're looking for the package type, not the word transistor. And there are a number of package types that transistors come in, but one of the most common ones is what we call the TO92. And it looks like this. So let's place him in there and we'll call him Q1. Q is a common word used for transistors. And once again we can toggle the orientation with the spacebar until we're happy. And there we go. Now of course our pads are looking a little bit small and the holes are quite large too. So what we can do is we can reduce the size of the hole and we can also change that pad style. So let's make them rounded rectangles, and my X size is actually going in this direction and my Y size is going in this direction. So I'm going to make that 75 and I'll make this 35. And now I've changed the pad style. That's going to allow me to get tracks in there, make a bit more meat for the solder to stick to, and it's also going to give me a little bit more room between the pads. So we'll do this again to pad number 2, make it a rounded rectangle, now as you can see our hole is quite large, and of course what we can do is I can actually make that hole a bit smaller for now. So let's make that 25 and matching pads in this component. That saves me doing it 3 times. Cool. Now I can make those a little bit wider, and I can even change the position of an individual pad to make it a little bit further out. But we've got to be careful that it's not too much of a stretch for the pins of our component when we physically go to put it in. Now let's add a string. A string is basically a line of text. And what I want to do is I want to have some text so that when the circuit board is etched and the blue layer, which will become the copper tracks, is finished, you can actually read a little bit of information about the manufacturer of the circuit board and perhaps the year it was made. So let's do that. We'll place a string on the bottom layer, and the text might perhaps have ABC 2012. We'll start with this character height of 60 pixels and a track width of 10 thousandths of an inch. And what we also need to do is we need to mirror. And the reason for that is because you must remember you are looking through the circuit board. As soon as I flip the circuit board over and I'm looking at the track side, that will read from left to right.